Hello. Today we're going to be talking about the Session Description Protocol, or SDP. So, Session Description Protocol is the standard that is used by SIP in order for two or more endpoints to communicate to one another what their various media options or codecs are. It's basically the process by which you can have two or more endpoints negotiate the media portion of a SIP call. When looking at the overall structure of an SDP message body or packet, what you can sort of see here is the basic expected kind of structure. And we're going to look at each of these individual attributes and what all of this means in terms of the different options and selections. So the very first field within your SDP is going to be your version attribute or field. So similar to SIP directly, you're going to find very consistent behavior here when it comes to the version, to the point that in probably 98, 99% of cases, the only version you're ever going to see is version 0. If you're working in a research and development role, or if you're in perhaps some kind of demo lab, you potentially might see something outside of version 0, but in live production networks and traffic, version 0 is going to be the standard. It's going to be what we would expect to see. After the version attribute, you have what's called the owner or the creator of this particular SDP message. So the owner or the creator attribute is going to uniquely identify the, owner or the generator of this particular packet. And generally speaking, the way that this identification sort of works is you're going to have some numeric string, and this numeric string can be something as simple as an extension. It could also be something like a DID number, but it basically is just a numeric representation of the owner or the creator of this particular session. In addition to that numeric identification, the owner attribute will also include things like the IP version that is being used by the owner, as well as their IP address. So the owner creator attribute is just simply a way to uniquely identify the person who is generating this SDP information. The next attribute down is what's called the session name, and simply the session name is just a text description that is human readable for this particular media stream or media session. Some vendors will have an actual description that's entered into this field. Others will simply include just a white space. And it will then appear as though the session name is empty. It's really not. It does have a white space in it. But because the session name is required to be present and is required to have something contained within it, a white space will meet that particular need. But in cases where there isn't a white space and there is some sort of actual description, that's perfectly fine, and is what the session name attribute is intended to be used for. It's a way for people to be able to look at that description and say, oh, this is for that particular call. Now, the next header down that we will sort of see, or the next attribute down, is the bandwidth attribute. Now, the bandwidth attribute plays sort of a double role here, but it is used to effectively communicate the same type of information, specifically how much bandwidth is going to be consumed by this particular media session. Now, there are two different structures for the bandwidth attribute. The first is basically a way to describe or limit the amount of total bandwidth that this call will consume, including all of the various media streams from all of the different participants in the call. In cases where you want to describe the limit of the entire call, you would use something called the conference total structure. Now, conference total, when you're implementing it with bandwidth, is just simply B equals CT and then colon, and then you're going to set the maximum consumption of bandwidth in kilobits. So in our example here, B equals CT colon 1000 is simply saying the total amount of bandwidth that will be used for this particular call is 1000 kilobits, or 1 megabit per second. The other structure or the other format that you could potentially see with SDP is where you're going to describe not the total calls bandwidth, but rather this one specific endpoint, either the caller or the callee, and how much bandwidth that one endpoint will consume. In that case, we're going to use a very slightly different structure, and it's going to be what's called application specific. So in this case, our bandwidth header or attribute is going to be described as B equals AS colon, and then in our example, 84. So that's going to basically say the generator, the creator of this particular SDP message body, that specific endpoint will consume up to 84 kilobits per second. So bandwidth can be either used to describe all of the consumed bandwidth across all of the parties in the call using conference total, or it can be used to define the specific endpoint's bandwidth consumption. And to be totally fair here, the application-specific bandwidth format or structure is significantly more common. The next three headers are where we start to kind of roll into the more session or call specific details. So the first header, the timing header, is basically utilized in situations where you need to define a specific duration or a specific interval over which media is able to be sent. And the way that that's done is there are basically two numeric values that you define. The first is the start time, the second is the stop time, and basically whatever that interval is, whatever that time period is, will indicate when media can be sent over this particular connection. It's not terribly common to have normal calls utilize this start and stop in time structure. Most of the time, a standard user-to-user or conference call will use something called a unbounded permanent media session. And that's implemented when you set up the start and stop time values to be zeros. So in our example here, the t equals 0 space 0, that is what sets up an unbounded and permanent media session. Now the word permanent is a little misleading here. It's only permanent so long as the call itself has not been disconnected. The next attribute down below your timing is going to be what's called your media information, or simply your media attribute. And in this particular case, what this will define is a couple of things. One, it'll define what specific type of media is being sent over this session, over this connection. The second is what IP port is going to be used to receive any incoming media streams. The next part is going to list what type of protocol is being utilized to send the media stream. In pretty much every case, you're going to see that it's going to be RTP/AVP. After the transport protocol is defined, the next set of numbers will be a list of media payload values which are tied into specific codecs that will be utilized. We'll talk a little bit more about that in the next section. So you have the type of media, the port that media is going to be sent on, RTP/AVP, and then you have your list of codecs. The last number, the most right number on this line, is going to be your RTP payload value, which is used for transmitting DTMF digits using SIP or over an IP network. We will break down the media attribute in a little bit more detail in the next section. The last header on that we're going to look at here is what's called the connection information attribute or header. So the connection information is going to give us the sender, the generator, the creator of this particular SDP message body. It's going to define their IP address that they want any media traffic sent to. So the connection attribute itself is going to be made up of a couple of parts. The first part is the direction that the media traffic is expected. In 99% of cases, the direction will be set to in, as it is in our example here. The next thing the connection information attribute will include is your IP version. So in this case, we have IPv4, so that would lead us to believe that we're going to see an IPv4 address. And the very last thing is the actual IP address being utilized by the sender of this SDP. So breaking down the media information attribute from the previous section just a little tiny bit more. I did say that the different media payload values, so from the previous section we have 8, 0, and 18. I said that each of those are mapped to a specific codec. Now, by default, each codec, or certainly all of the common ones, G711, G729, G722, these all have default media payload values that are included just as part of the SDP protocol itself. However, you can use the last attribute that we're going to talk about, the media attribute, to change those default settings. So just by way of an example, the A equals RTP map :0 PCMA/8000. What does all that mean? Well, PCMA/8000 is G711 A law. And what we're basically using this attribute line for is to take that A-law codec and specifically map it to the media payload value of 0. Normally, or perhaps by default, G711 A-law is mapped to a media payload value of 8. But we can change that default setting by using this RTP map media attribute. There are a number of different other potential media attributes that can be utilized. For example, you can see some for encryption. If you're going to enable SRTP, the media attribute, attributes can be used to list out the various encryption algorithms that you'll use. There are also some codecs, G729 for example, does potentially have some additional choices or selections that can be made, and you would use your media attributes to set up those options and those choices and selections. Now, going back to our codec discussion here for just a moment, if you are not going to change any of the default mappings, so if you're going to use 8 for G711 A law, 0 for G711 mu law, 18 for G729, and those mappings are fine for you, you do not have to include any RTP map values inside of your message body or specifically with your SDP. However, for readability and ease of confirming whether or not the appropriate codecs are being offered out, it is a good idea to include them even if they're not required. So the last section, the last note that we're just going to touch on here is the overall media negotiation process. So when a call is initially being set up, the caller will send out their full list of available options and selections. They'll send out all of the codecs that they support. They'll send out all of the different encryption algorithms that they support. And it's up to the responder or the callee to make a selection from all of these different options to basically lock in what will be used for this particular call. Now, when it comes to the order that the codecs appear in on the media attribute line, the order is important because it's a preference order, meaning that whichever codec is furthest to the left is the most preferred, whichever codec is to the furthest to the right is the least preferred. And the idea is that the responder, the callee, will try and match as closely as they can both sides' most preferred codec. Now, if during initial call setup there is some sort of problem or issue with the negotiation, very commonly when both sides don't have a shared supported codec, the call will fail at that point without any user necessarily having to answer or interact with their phones beyond simply dialing a number. And when there are no shared codecs or when there's no shared encryption algorithm, the responder usually will send out a SIP error code of 48 not acceptable media, indicating that there is something inside of your SDP which the responder was unable to find a match within their own list of supported options. So putting all of this together, SIP as a protocol does not include a way natively to communicate media information or media details between parties involved in a voice or video call. SIP was extended to include or to add this media negotiation capability through the session description protocol. And again, session description protocol is added or is included in the message body of particular SIP messages. SDP itself is made up of a number of different attributes. We've covered most of the major ones as part of this session. And these attributes are what are basically used to either communicate information from one side to the other, or they're used to negotiate the specific parameters that will be used for this particular media session. So I'd like to thank you all for coming to this particular session, and we will see you in the next one.